If I could, please, could everybody take your seats? Thank you. Okay, I would like to say thank you for all of you that got up early in the morning and got your cup of coffee and came on in here. We appreciate that. We are going to start plenary number 5, and it's entitled Monitoring Freshwater from Space with a Focus on Africa. Monitoring fresh water is perhaps one of the most key things we can do from space. It provides us a global point of view on a uniform and well-calibrated instruments. And following fresh water is absolutely critical to all of us here. All terrestrial beings need that fresh water, and it is one of the fundamental objectives that we have in earth science is to understand the hydrological cycle and the elements therein. So what we're attempting to do today is to bring you a 3-part message. The first is, how do we make the measurements typically? The second one will be, what do we do with the measurements when in fact we've got them in hand? How do we use that and apply them to everyday life? And then the next question will be, how do we take that information and apply it to the future? How do we form policy with it? So we have 3 distinguished speakers today, or actually 2, not including myself. I will start off, I will talk about the measurements from space, but my 2 distinguished speakers, the first one is Dr. Ahmed Araji. Ahmed Araji. Dr. Araji is the project manager of the Royal Center for Remote Sensing in Morocco. His efforts focus on the application of remote sensing for water management, global monitoring, desertification, and natural hazards. He received his doctorate in structural geology and a master's degree in remote sensing. He's the principal investigator of the Tiger Project Phase 2 and a member of the project GMES for Africa. He will talk about the models and essentially give you some practical examples of how we're taking the data and applying it to models and actually using it today. Our second distinguished speaker is the Honorable William Atacello, and he's a member of Parliament in Kenya's National Assembly and was Director General of the Regional Center for Mapping of Resources for Development in Kenya from 2000 to 2007. He has over 30 years of working experience in natural resources, assessment and management, environmental conservation, and land use mapping and planning. He's also has wide experience in the application of remote sensing and the Geographic Information System, GIS, in mapping natural resources and assessing them. He has a master's in biology and also a PhD in natural resources planning, assessment, and management. So we will attempt to show in the next hour how we're making the measurements from space and how we're using those measurements here on Earth. The basic format that we will be using, I will talk for about 10 minutes, and then each one of my co-speakers will talk for 15 minutes. Then we'll have a few panel discussions questions up here. We are soliciting questions from the audience. We will have an individual who will, if you raise your hand, she will give you a form, and you can write your question, raise your hand a second time. She will collect it from you right over here. And then she'll bring them over here to Brent, and they'll bring the questions up here to the stage. So without any further ado, let me get into the actual presentation itself. Again, we're going to talk about the 3 elements, the measurements, the modeling, and the decision support. Those are the 3 crucial things that affect us today. The water cycle, as you all know, is very complicated. We have, in the lower left, we'll have the ground storage, we have the soil moisture measurements, the ocean plays a vital part in it as it does to water vapor, and precipitation. The elements that I've circled are going to be, I'm going to talk very briefly about those particular elements and how we make those measurements from space. Now this is a acronym soup for many of you, but it discusses many of the elements that we've got in the hydrological cycle, the precipitation, the soil moisture, and the acronyms represent missions that are flying or will be flying that make those critical measurements. The ones in reds are the ones I'm going to talk about, and I've selected those because they have a strong international flavor. Not one country can actually make this measurement, make all these measurements. We have to have an international group to be able to cover them all. The first mission I'm going to talk about is GRACE, which is the Gravity Recovery and Climate Experiment. GRACE consists of two spacecraft that fly in orbit in tandem, and they measure the distance between the two spacecraft, and they're able to determine the Earth's gravity. Well, fundamental on that is the ability to be able to measure mass change, which impacts the gravity. So that this experiment that was actually put up to measure gravity is actually also able to measure the change in mass, large mass changes. So on the ice caps, it can measure the reductions that are happening there, but it also can measure changes in aquifers underneath the water. Underneath the surface and on the surface. Both in the last year, it's made major measurements on the increase. Blue here represents an increase of on the order of 5 centimeters equivalent water that's happened in the last year down in Australia and in the northern part of South America. So GRACE is able to penetrate the surface and look beneath there at the aquifers. One of the other elements that in doing this, it's looked at aquifer in India and Pakistan and determined that in the last 6 years, that aquifer has lost the equivalent of 109 cubic kilometers of water, which is the equivalent of 3 Lake Meads, a very large reservoir in the southern southwest United States. But bringing this back to Africa, what you're looking at here in the colors, on the left is the image of Africa. The blue shows you a reduction of about 4 millimeters per year in the soil and of the water in the aquifers over a period of about from 2003 to 2006. And over on the right, it shows you the replenishment, the recharge that's happened in those aquifers over a 5-year period of roughly the same amount, about 4 millimeters of water per year. So with this, we're starting to penetrate the surface. We're starting to look at the aquifers. Certainly look at precipitation is vital to all of us, the rain that comes down, and TRMM has been flying now for about 11 years or so. It's a combined JAXA and NASA mission, and with its radiometer and its precipitation radar, it's able to measure rainfall and produce global averages and anomaly. It's crucial for following and tracking what's happening with the rainfall throughout the globe. This mission is getting old, so it's going to be replaced probably in 2013 with the Global Precip mission, which will take the same sorts of instruments and move them one step further. This is also a JAXA and NASA combination. Certainly, right around the corner is a launch, Megatropique, which is a combined French and Indian mission to look at the water cycle in the tropical atmosphere with their microwave imager, their radiometer, and their microwave radiometer, the 3 basic instruments. They're going to be looking at the atmosphere, and it's designed to go after the hydrological cycle. And it's going to be launched October 12th, so just in about a week from now. So we're moving from things that are flying and are about to fly to things that will go in the future. There is a mission, ESA mission called SMOS, which is measuring soil moisture. There's also one that's going to be going up in 2014, which is a Canadian NASA mission, which is called SMAP, Soil Moisture Active Passive, and what it will do is also measures soil moisture. It has two instruments, as a radiometer and an active radar that'll be used to make those measurements. It has a 6-meter diameter mesh antenna, which is deployed on space and rotates at about 15 RPM. This gives it a very large swath, and as you can see in this image, the coverage in one day will be enormous. So we'll be able to cover within 2 to 3 days the full Earth and be able to measure the surface, the soil moisture with it. Now, all of these are research missions that I've been talking about, but there is a big push now to look at applications and operational use of some of this data. So SMAP actually is starting to look at taking the research, taking the data and moving it into the applications area. And these are some of the investigations that are going on or is proposed to go on with the SMAP data. And you can see that they're going to look at cropland monitoring, forecasting, and at the bottom we actually have from the UAE an investigator mapping the Sahara Desert emissions. The last mission I'll talk about is SWOT, which is the Surface Water and Ocean Topography mission. This uses a Ka-band interferometer SAR to create 2 SWOTs, each about 60 kilometers wide. And it's going to look at, over salt water, it'll measure the topography of that. But for our purposes here, it's going to be looking at the global inventory of terrestrial water bodies. So it'll be able to focus in on rivers and lakes and get the heights of those lakes. So for the first time, we'll really get a global comprehensive measurement of large lakes and rivers. So that covers some of the missions that are flying and some that will be going in the next decade. What do we do with this data? Different agencies, different organizations take this data, they fuse it together into applications that can help us today. One, which is the USAID, has taken data from Earth orbiting spacecraft and instruments, MODIS, AIRS, and in particular TRMM, which is what I talked about earlier, and fused it together to study the crops, the performance of the crops and the soil, and determined what they call as a famine early warning system to be able to look at the croplands and how healthy they are. Another one is looking for the regional water balance, and it's fusing GRACE with other data sets to produce and look at Middle East and North Africa in terms of the water resources there. And lastly, I'll talk about SEVERE, which is a program which disseminates the data. You all have to get access to the data, and we have programs in place, TIGER, as well as SEVERE, which disseminate the data freely and openly, so they're accessible. One of the nodes for SEVERE is located in Kenya, and in one example, they've taken the data again from TRMM, the hydrological models and GIS tools to go ahead and generate floodplain maps for Lake Victoria. So in summary, the hydrological cycle is crucial to our survival. It's a very complex system that requires us to investigate the atmosphere, the land, the terrestrial bodies, as well as the ocean, and mix them together. And to get those measurements, we really need a consortium of international missions, which some of which I've talked about today. After we get that, we have to create models or products from them using models, and those models have to be well established. And lastly, then we have to figure out what we're going to do with that and how we generate the policies which will drive us in the future. So that's the end of my talk. What I'd like to do is turn it over to our first speaker, Ahmed, who is going to talk about how we take the data and how we apply it through our models into our everyday living. Ahmed?
Hasn't worked.
I was having some trouble. Oh, let's May we boot up the second talk, please?
Forward, is this one?
No, this one. Middle one. Middle one. Yeah, I was pushing the wrong one.
Okay. Okay. Thank you, moderator. Honorable audience. My talk is based on case studies that have been carried out within the Tiger Initiative at our level in Morocco. I'm not going to talk about this initiative. I've seen some designers working around. I think they can talk about it better than I can do. But I'm going to show you that we have what we have done within this Tiger Initiative. So these are, as I said, case studies. The first one was carried out in the Souss Mesa region with the collaboration of the local water authority, which is the water authority of the hydraulic basin of Souss Mesa. And the objective of our study was to strengthen the capacities of these local water authorities for an integrated water resource management approach, draw and operational exploitation of Earth observation. So the region, where should I point this?
No, it's the third one. No.
Yes.
This one right here.
Yeah.
There you go.
Okay, the region is localized in the central part of the country. The Agadir city is localized somewhere here, for those who can recognize it. The region is characterized mainly by irrigated agriculture, which is consuming more than 95% of groundwater. And in terms of water potentialities, it has some surface water potentialities around 800 million cubic meter. And it has some main aquifers, mainly these two main aquifers, Souss aquifer and Stuka aquifer. These aquifers, as you can see, are facing a very severe negative situation during these decades. So this is the main problematic. And the idea of our study is at the first level, we have to focus on the watershed level, and then we will study some specific area. The first one localized at the upstream, where the problematic is mainly related to the new irrigated exploitation area. And the second one localized in the mountainous area, and the problematic is mainly related to the use of Earth observation data for assisting our local partner to better define some aquifers zones because of water scarcity in this area. And of course, there was an accompanying action, mainly through knowledge transfer. And in this context, we used the Tiger Initiative facility. So we have done many, sorry for that. We have done many training sessions at our level, and also some of them were also organized through the Tiger Capacity Building Facility within this initiative. Our approach is mainly based on the use of Earth observation data and the existing data in order to establish a geographical database at the whole region for producing decision-making product. So what we've done was based on different kinds of data, of course, optical and radar data that were available through the Tiger Initiative, and also data that we acquired by our center. Also, we used some different processing techniques. As you can see, some fusions between optic and radar. It was very helpful for land use mapping. So for this case, we produce different situations since 1987 till 2008 with very specific legend where we focus on irrigated area. And in this specific legend, we distinguish between the public and the private sectors in terms of irrigated area. So as you can see, the first statement from this study, the territorial dynamic at this region is very diverse. We have different kind of change in this region. Sometimes these are related to the over-exploitation of the aquifer, sometimes related to deforestation, sometimes related to urbanization and such. But in order to better understand what is going on as dynamic, we said it will be better to integrate different situations, mainly the intermediate situation, because we may talk about the change at this region just using the first stage and the end stage, but using this, the intermediate situation will give us an idea mainly about what we call the permanent irrigated zones and the temporary irrigated zone. And this was very helpful for our local partner because they want to detect and to localize where are the new irrigated exploitation, mainly within the forest domain, which is prohibited by law. So our approach was based on this concept. As you can see, in terms of changes, land use changes, related to appearance or disappearance of this irrigated area, they are closely linked to the spatial distribution of these main two aquifers. Outside, we don't have really significant changes, apart some new dams during all these 20 years. So, using this information derived from Earth observation and coupling this with the hydrogeological modeling of these aquifers. As you can see here, you have the situation of the water table depletion since 1968 to 2008, and we can really understood what is going on in terms of water pumping and water consumption. These are three main sites. The first one, which is localized in the central part, and where farms are really closing, and there is now enough water for more irrigation. The second one, it's an intermediate situation. I will talk about it later. And the third one, it's localized in the upper stream part of the watershed. And this upper stream part is very crucial because it's localized in a very specific hydrodynamic region. And I have just to tell you that in this area, you have the fourth high mountain in Africa, which is receiving a lot of precipitation. And it's really contributing to the recharge of all these aquifers. And if the situation continue as it is in terms of water pumping and water consumption, the situation, of course, will be very dramatic for the whole region. So for this, we simulate the behavior of these aquifers based on the current situation in terms of water use. As you can see, the situation will be very dramatic. We will assist, or we will have around 40 to 50 meter depletion added to the 60 that we have since 1968. And in this region, it will be very, very, very dramatic. And of course, it will compromise all the future for the remaining part of the aquifer. I have to tell you here that this region is contributing for more than 75% of our orange exportation that you probably had tasted before. So, focusing on this area with specific data that we've got through this Tiger initiative, and also that some of them we bought, and with the specific legend, I have just to highlight this red one, which is representing the plots that are newly prepared for future irrigation. And this was very helpful and useful for our local partner because they can detect this area before they start pumping, and they can, of course, go on the ground and stop them. So this kind of product were really useful for our local partner. These are some photos that we've took from the ground. As I said to our colleagues in the IEF workshop, I'm showing you these photos not to tell you that I was on the field, but mainly to tell you that Earth observation is not only satellites in hundreds of kilometers above our heads, but also feet on the ground. We've been on the ground and we've seen the dramatic situation. As you can see, agricultural practices still very old, although there are many important efforts that are carried with by our local partner. These old practices are very consuming of water. And let me just comment, for example, this one. This situation, sometimes the farmers are facing a very critical situation where they have to choose between trees, which to keep and which to cut, because there is no enough water for the all exploitation. So this one also is very sensitive to me. This farmer is taking his tank and he go 10 kilometers away from his house looking for water in order to supply his family and also in order to irrigate some trees that he kept. Of course, the situation ends by this. So they cut all the orange trees, they close their exploitation, and they migrate to the north, to the upstream, which is, as I said, the critical hydrodynamic characteristics which is contributing for groundwater recharge. So for this issue, in terms of groundwater recharge, we did some hydraulic modeling for our local partner in order to optimize what is the optimum volume and what is also the good time for releasing water from the upstream dams that were installed mainly for this objective. So we give them some recommendation, and of course they take them in their account. So the other side, where the situation is very different, which is the mountainous side, we did some modeling based on the so-called weight of evidence modeling, and this method takes in account different hydrogeological predictors, which are the geology, the surface drainage, geomorphology, and the potential recharge zone. All these were derived from Earth observation data. So these are the product or the hydrogeological predictors that we used. So let me show you just the last one. I don't have enough time. So this one, which is very important. So in this region, the aquifers are discontinuous and are mainly localized in the fractured area. We used the radar data in order to identify and to map where are the potential zones that may retain for a long time the rainwater. And these zones are interpreted as zones to be interesting for groundwater recharge. So our product is this map. So this gives us an idea about what is the potential, the hydraulic potential at this area. We give our partner this site for let's say, optimize their groundwater prospecting processes. So to finish, I've just going to show you some results that we carried out during the second phase of Tiger, because in Tiger they're still going on the second phase. We are also involved in it. So the area is different, is localized in the northern part of my country, and it's receiving more water than the southern area. Let me show you just some product. These are some also product that we elaborated based on a rapid mapping tool that we installed, because this area is facing a very severe also situation in terms of flooding. It was the case during 2009 and during also 2010. So these are our products that we give to to the local authorities to better manage the crisis period. So these are also some products that are derived during this phase. They still, let's say, at a preliminary stage, but we used some modeling for water balance estimation. The model that we used is called SEB, Surface Energy Balance System, based on the radiative and energetic balance for estimating one of the key hydrological parameters, which is the ET. you have one image of the ET per day, and what we have done till now is this kind of water balance. It's very simple, let's say, method for estimating water balance. It's called climatological water balance. We used the rain or the precipitation during one period and the evapotranspiration, and we estimate what is going on in terms of water change or water storage change during this period. So as you can see, there are some periods where we have a positive water balance and also where some area where we have a negative water balance during this period. I have just one. And this one is the last one, is Out of Tiger initiative. Just to tell you that we are also working in parallel on other projects. This one is called the ELDAS Maroc, the Land Data Assimilation System for Morocco, that James talked about later. And we are involved in this context in order to develop 4 main applications. All of them are for the whole country, and we will focus, of course, based on different topics on some specific area. For example, for water balance issues, we will focus on hydraulic basins in terms of climate change impact in the past, the current situation, and in the future. For irrigated area, we will focus on irrigated perimeters with collaboration with the local authority in charge of this irrigated area. And we will, of course, focus on water use, water requirement, and the climate change impact based on the future hydrological conditions. And the third one is related to the drought monitoring, where we will focus on agroecological zones with the agricultural ministry. And the last one, this may be linked also to FEUS-NET project that you talked about, Dr. Jim. It's related to locust combating migration. As I heard during the IEF workshop, Sahara is getting green. It's really a main issue also for us. And we will focus on the north because here we have the main element at risk, which is the agriculture issues. Thank you for being a little bit long. Thank you for your honorable audience.
So now we've heard about the measurements. We've heard about one example of how we take those measurements and apply it on the ground. And now I'd like to introduce Wilbur, and he's going to talk about how we take that and fold it into policy.
Okay, is the third one? Yeah. I will start my talk by giving you a quotation by Thomas Fuller, 1732. He said, and I quote, "We never know the worth of water till the well is dry." My presentation will be as follows. I'll give you an overview on water status in Africa, the challenges that we are facing in water use and conservation, examples of how we monitor fresh water from space, and policy implications and a few recommendations. Africa is one of the richest continents in natural resources and ecosystem services. It is endowed with vast amount of water, both surface and untapped groundwater. We have very many water towers in Africa. Among the biggest are the Congo Basin, Lake Victoria, Rift Valley Lakes, the Nile Basin, and many others. Per capita water consumption in Africa is among the lowest in the world. That is about 31 cubic meters per year. If you compare, for example, with North America, which has 221 cubic meters per year. Water consumption in Africa is increasing, particularly due to increasing population. If you compare the available water resources, that is the internal renewable water resources worldwide in relation to Africa, you find that Africa has only 9% of the world water resources. And it's one of the continents that has water scarcity problems. In Africa itself, if you look at the proportion of renewable water resources by sub-region, you find that Central Africa is the region that has the highest water resources, followed by West Africa. Eastern Africa, that's the Great Horn of Africa, has the least water resources. And that's why every year we have lots of problems of drought and hunger in this region. That's the map which shows some of the major water towers in Africa. That's a map which shows the total renewable water resources in the entire continent. And you can note that the Central Africa has the highest water resources. That shows the per capita, which also follows the same pattern. This map shows the annual water balance as an estimate of the available groundwater after evapotranspiration. So again, you can see Central Africa and West Africa has the highest water resources. What are the challenges facing sustainable water conservation and use in Africa? One of the key problems that is facing this continent is the provision of water for food security. This is a problem that has to be tackled using various approaches, because food is a major issue, particularly in the Greater Horn of Africa, due to scarcity of water. So the issue on how we can provide this scarce commodity is very important. The other challenges are the environmental degradation. Most of these areas, particularly in the Greater Horn of Africa, have been degraded through human activities, mainly clearing of forests and land degradation. Then there is the issue of climate change, which has a major impact in the arid and semi-arid lands in Africa. So this is an area that we need to look into for the future of this continent. The issue of water pollution and siltation is a major issue in most areas in Africa. And again, this is due to human activities. Other issues include the invasion of water bodies by water plant species, which actually make the water unavailable. Then, of course, there is the increasing population and the increasing demand for water. Currently, in the Greater Horn of Africa, one of the key problems is the civil strife and conflicts based on water. During dry season, the major conflicts in the region centers on water. Earth observation has been used extensively in Africa in monitoring water resources. This is because this is one of the most effective methods of monitoring our water resources, given that ground methods are very difficult due to lack of communication and other required facilities. Earth observation data has been used extensively to monitor and map siltation and pollution, map and track invasive plant species like the water hyacinth in Lake Victoria, and determine reservoir levels, among other applications. It has also been used extensively, as it has been shown here by my colleague, in monitoring groundwater vulnerability to pollution and recharge. There are numerous examples of the use of Earth observation in monitoring water resources in this continent. I will not endeavor to give you numerous examples, but I've only chosen a few. Quite a number of these examples, I chose them because I happen to have been one of the members of the programs that carried out this work. One of the key programs that has used Earth observation extensively is the Lake Victoria Water Quality Mapping and Monitoring. This is a program that was funded by European Space Agency in collaboration with the Regional Center for Mapping of Resources for Development. The Nile Basin Catchment, that's land use and land cover mapping. Flood forecasting and early warning using the CREST model, particularly the project that Jim referred to, the Severe Africa project, which is funded by USAID and NASA. This is a project that's based in Nairobi and is used to provide early warning information on flooding in the entire continent. We have also used Earth observation data in the management of water resources in the Rift Valley lakes, and this is a project that was funded by the French government. TICA program is a program that has had a major impact in Africa in terms of using Earth observation in monitoring our water resources and coming out with hydrological water models and other information. This is a project that has created a lot of capacity in Africa, particularly in our academic institutions, where various researchers have been funded through the TICA program to undertake various programs. These are some of the examples that we've used Earth observation to create information. This is flood forecasting using the Severe CREST model. This is an example of where we've used severe modeling to give information on flooding on Zambezi River in March 27, 2009. These are some of the detailed analyses of the areas affected by flooding. This is an example of mapping of water surface quality using radar images. And this is on Lake Victoria. Lake Victoria is having a major problem with water, with the invasion of plant species called water hyacinth, which has covered most of the lake due to pollution of the lake. And we have used radar images to map the extent of the distribution of water hyacinth on the lake. Due to this invasion, some of the areas, some of the ports on the lake have been closed down. Earth observation has been used again to carry out water quality assessment, and this is on Lake Victoria, where we have calculated total suspended matter, total chlorophyll, and other materials. Using both satellite radar altimeter data plus ground information, the levels of Lake Victoria has been monitored since the year 1900 to date. And you can see areas where we have had fall in levels of Lake Victoria, mainly due to the start of the hydroelectric power station on River Nile in 1954, and again 2007 when the second hydropower station were commenced being built. Yeah. Earth observation data has been used extensively in monitoring particularly flooding and droughts in the Greater Horn of Africa. And these are some of the examples. Over a long time, this is Lake Chad. Using Earth observation, changes in the levels of Lake Chad have been monitored since 1973 to date, and you can see how the lake levels have changed, mainly due to siltation and variation in rainfall pattern in the region. So what are the policy implications and future sustainability of water resources in Africa? It's worth noting that Africa is one of the continents which is water scarce, and over 348 million people have no direct access to water in comparison to the world figure of 884 million. This is a major problem for the continent, and there is a need for policy intervention if this problem has to be resolved. One of the key policy issues is how to conserve the available water so that it can be used for food production, because there is a direct relationship between water availability and food security. So we need to come up with policy directions that will ensure that the available water resources are conserved and used effectively and efficiently for the use for both agricultural production and human use. We also need to create public awareness on the importance of water resources in the light of the fact of the impact of climate change on this very vital resource. Land degradation is a major issue in the continent, and it's very, very important that major public awareness programs must be put in place to ensure that land degradation is tackled in a way that is minimized and degraded areas are restored. So again, that's where we need a major political intervention plus the local people. Over years, floods have continued to increase in the continent. From 1900 to the present, you can see that floods have been on increase. Equally, droughts have been on increase. Not necessarily the floods have increased because the rains have increased. Not necessarily. Floods have increased because of many various reasons. One of the major reasons being land degradation, clearing of forests, cultivating on steep slopes has led to major runoffs, so that when we have even very little rain, there is major runoff which causes floods downstream. Equally, due to climate change, drought episodes are increasing in Africa, particularly in the Greater Horn of Africa. So this is an issue that has to be tackled policy-wise. We must put in place policies that will ensure that issues of floods are addressed through major disaster management interventions. Issues dealing with drought are mitigation measures and adaptation measures are put in place to ensure that we can cope with the drought. So one of the major recommendations is the use of Earth observation technologies in rapid acquisition of reliable data and information for decision making and for sustainable planning. In conclusion, I can say Africa is endowed with vast amount of fresh water and untapped groundwater that is rapidly declining. The per capita water consumption is among the lowest in the world, and yet the demand is increasing. Water resources are facing serious environmental and climate-induced challenges, and there is a need for immediate intervention. Therefore, there is a need to formulate and implement policies and legislation that address these challenges. And lastly, the issue of Earth observation data is very important and should be one of the issues that should be included in the policy prescription so that Earth observation can be used effectively in collecting data that is essential. Thank you very much.
Hello? Okay. We're a little pressed for time, so we do have some questions that have come in from the audience. I thought we might try them. Before we get into the question issue, I do want to just, well, let's get through questions first, then I'll come back to that. First of all, there was a question for both of you, which is there effective dialogue on water issues among the leaders of African nations? So the question really is, how much is there an iteration, discussion on these issues between the nations themselves? Wilbur, perhaps you want to try to take that?
Thank you. Yes, there is effective dialogue on water issues in Africa, particularly at a political level. Within the African Union Secretariat in Addis Ababa, we have a division that addresses the issue of water resources in Africa. But the most important issue is that at a political level, at a regional level, this matter is discussed. But we need to take it from discussion, from conference rooms to action. So this is where individual countries need to come up with their own policies to address the issue of water. And I'm aware that quite a number of countries, particularly in the Great Horn of Africa, are putting a lot of emphasis on water because that is the basis of survival in that region.
Okay, thank you. A question really for Ahmed, and that is, if you're an investigator and you want to get a hold of some of these models and some of the data, how would you go about in doing that? How do you reach out to grab the data and make it, and be able to use it for yourself?
Okay. You should contact me first, I think. No, I'm joking. I just talked about the Tiger Initiative. It's one of the most important opportunities that exist. Let me tell you one saying that we have in my country. If somebody didn't learn how to climb the hill, he will live all his life in a hole. So it's a matter of learning. In our center, we didn't start from scratch, of course, but we used Tiger opportunity to improve and to develop our endogenous capacities. I can give you an example. In Tiger, I was involved in three projects. One with the Canadian Space Agency and two with ESA. One of these two projects, we had as partner a university in my country. I know people from this university. They don't have any experience with using Earth observation data for such application. But now they were able to establish a very good program in their university and to establish a professional bachelor degree. And very soon they will launch a master degree. This is really a matter of learning. So if I want to resume, if there is a will, if there is opportunities such as Tiger and others, funds, support, scholarships, and of course, if there is a reason of it, we can do it.
Thank you. I think we have time for maybe one, maybe two more questions. One question was, what are some of the problems that the African countries face in inserting models and products into the decision-making process? So they're interesting to see what kind of impediments and obstacles that you face in trying to infuse this knowledge into your decision-making process.
Thank you. one of the major problems African countries are facing when it comes to water problem issues is the enaction of legislation that should be used for management of water resources. For many years, many African countries have had no serious policy and water legislation. And as such, water resources have been mismanaged for a long time, and particularly when it comes to land degradation and pollution. So that is an issue that is of long-term nature, but I'm happy to note that due to the importance of water, many African countries have put in place policies and legislation for management of water resources. The only challenge is how to implement those policies and legislation. That's where the challenge is, and given that they have no sometimes enforcement to enforce the use of water resources properly in certain areas, you find that there is a lot of misuse of water resources in many areas.
Okay, thank you. One more quick question, which is, how do you, Wilbur, interface with the modelers and the data producers? And Ahmed, how do you interface with the decision makers? You know, how does the information get transferred?
Yeah, in our case, we interface with decision makers in two ways. The first way, when it's a matter of short-term concerns, we interface with high-level policymakers. I mean, when it's matter of hazard, for example, or some specific needs, we interface with high-level policymakers. But with local-level policymakers, we interface. We interface with them through technical departments. It was the case, for example, in the study that we carried out in South-Mesa Basin. I show you a very dramatic situation on the central part where farms are closing. When we start working on that area, the product that we produced were used to support a very huge decision, which is to implement a public and private agreement for carrying out and bringing water from the upstream dams to the central part for more than 100 kilometers. And it was done. So our interface is these technical departments at local level.
At political level or at a law-making level, like in my parliament, we have various departments which address different issues in different sectors. And each of those departmental committees interact directly with the relevant sectors. Like in the case of water, we have a committee that deals with agriculture and water. So when we need to get any information on water issues, that committee will summon the technical people who are involved in water issues. And they will appear before the committee of the parliament, where then the issue will be discussed. And if need be, programs are then prepared where the issue is discussed in various national or regional fora.
Okay, thank you. I think our time is up. The speakers will stay up here if you have additional questions or issues you would like to talk to them about. I would like to point out that there's our plenary 6, which happens this afternoon at 2 p.m., Next Generation Visions from Earth Observations in the 21st Century. These are the young professionals who will be talking about their interests. And then tonight, the highlight lecturer is Dr. Mike Freilich. He's the director of NASA's Earth Science Division, and he'll be talking in this very same room at 6:15, so I encourage all of you to attend. I would like to thank our speakers for coming today and for enlightening us on how we are using and the models and influencing the policy in relationship to freshwater here in Africa. Thank you. Thank you all.